Brian Ng. We did our project on automatic cartography, the utilization of self-operating robots to digitally compile maps.
So our goal for this project was to program a Scribbler robot, as you've seen before, to self-navigate through any given room or area and using sensors, pick up data, and using that data, convert it into some meaningful map or grid that you can see.
So we also used the Scribbler 2 robot, which is the little red circular thing. And attached to it, we added an IPRU fluke board, which added Bluetooth capabilities, which allowed us to contact it via the computer. It added IR sensors, which we used to detect if there was an object in the way. It also added a color camera, but we did not use that.
And for software, you use the Calico programming environment, which uses the Python programming language. And we also use the Miro library, which includes many basic functions, which allow us to communicate with the Scribbler robot.
So there are two main parts to our project. The first part was navigating through a room and being able to get data points for every part of the room to know if there's objects in the way or not. And the second part is taking this data and creating a meaningful map. So the first part was we had the Scribbler move in intervals around 15 centimeters throughout the entire room. And every 50 centimeters, it would rotate 360 degrees and take 4 data values: forward, to the right, behind it, and to the left. And these would return as either true, that there was an object in the way, or false, that there was no object in the way. In addition, we constantly tracked the X and Y coordinates of the Scribbler so that it could create a list of 6 digits, the X, Y, and the 4 obstacles. We took this list of 6 digits and combined all of them into a master list, which we then ran through a sorting algorithm to create a map.
So challenges. Even though this project may seem like really simple and straightforward, it was actually quite complex. So our first challenge was the sorting algorithm. So this pertained to displaying the grid and taking the data and making it into a map. So we had these 6 data values, and we had many of these, so we had to find a way to convert these into some meaningful way to display it. So the way to do this was we wanted to first use arrays, but we found out that if you wanted to use arrays, you had to define the dimensions first, and we didn't want to make our rooms static. We wanted them to be dynamic, so our Scribbler could adapt to any environment. So we ended up using lists and lists, but as we started using more lists and lists, we started confusing ourselves, and it became more sophisticated. So that was one challenge for us to clear our minds and refresh ourselves.
The second challenge was from navigating the room. So the Scribbler doesn't turn 90 degrees every single time it turns. It might turn 89 every time. And if you turn a lot, then it would eventually get really off, so we had to calibrate that. In addition, in order to create a map of the entire room, Scribbler had to travel through the entire room. So we had to make sure that it went through every square. We solved that by simply having it go down in rows, columns, and when they encountered an obstacle, we'll simply move to get around the obstacle.
The application. So let's say all of you guys are firefighters, and you've been called to a job. So you want to get inside this building that's on fire to put out the fire and to save anyone in it. But you want to do that without harming yourself. So you can send this robot inside to map the building, and so that you get a sense of what you can expect in the building without killing yourself, because there's many firefighters who kill themselves on their job, which is kind of ironic.
So this is a little bit of sample code. I know it's kind of hard to see. So this part right here is the navigation of the robot to get through the maze. You can see several different segments. And this right here is the sorting algorithm in order to output the data. And a really important part is we had problems getting lost in our code because we had around 500 lines of code, and we made sure to comment a lot later on so we would know what we're doing.
So conclusion. So through this project, we've concluded that it is actually possible to use a robot and to map out rooms with it. And after doing some research, we found that there is actually technology for this, but we feel like this technology is still not the best technology, and there's much room to expand in this area and field of research.
Here's our video demo.
So right now, the Scribbler is starting out and moving down the column, and it rotates clockwise and counterclockwise so that it doesn't mess up its turn.
Let's do this setup 4 times. The Scribblers don't move anywhere close to this side.
And here it comes with encounters the first object, and it navigates around it.